Where did the moon come from? How was it formed? Throughout history, many people have sought answers to these questions. Dozens of theories have been produced on this subject. For example, could a planet the size of Mars have crashed into the Earth? Scientists upload all the data they have to a supercomputer. They prepared a simulation of such a collision. According to this study, which is one of the highest resolution simulations ever made, the moon during a major collision, and get ready, may have occurred in just a few hours. There are over 200 natural satellites orbiting 8 planets in the solar system. But their distribution to planets is quite interesting. Starting from the outermost planet Neptune 14, Uranus has 27, Saturn has 83, Jupiter has 80, and Mars has 2 moons. Earth is the only planet with a single moon. Moreover, the closest natural satellite to the Sun is the Moon. That's because Venus and Mercury, classified as inner planets, have no moons. In other words, the Moon is a very special celestial body in the solar system. It's not the biggest satellite. For example, Titan orbiting Saturn is twice as large, but if we look at it, Saturn is almost 10 times the size of Earth. Comparing the size of the satellite and the planet it revolves around, the Moon is breaking a record again. Among all the moons of 8 planets, by far the largest on its planet. Looking at other planets and their moons, we see tiny celestial bodies orbiting huge objects. However, the Moon is almost a quarter of the Earth's size. Because of their proportional size, some astronomers, he even considering the Earth and Moon as a binary planetary system. So, what happened to the satellite with these interesting features? The main ideas put forward in this regard are as follows. Aggregation hypothesis. Earth and Moon in the early solar system. Particles and gases from the accumulation disk or from a black hole as a binary system. Suggests that they were formed simultaneously and together, but with the amount of iron in the Earth's core. It cannot explain the reason for the difference in the amount of iron in the Moon's core. Cleavage hypothesis. That the Earth, which had formerly rotated at a much greater speed, ejected a part of its mass. And that's what he claims turned out to be the Moon. This thesis was first proposed by George Darwin, son of the famous biologist Charles Darwin, and has retained some popularity until the Apollo missions, the manned voyage to the Moon. It was later discredited. Capture hypothesis. He argues that the Moon actually formed in another part of the solar system. But after a while, when he got too close to Earth, slowing down, falling under its gravitational pull. The weak point of this idea is he couldn't explain how the Moon slowed down. All of these and similar hypotheses have weak points. All this before going to the Moon. It was based on observations from Earth, and there were also some inconsistencies in the mathematical calculations made on paper. Then there were 2 important developments. The computer was invented and the Moon went. The astronauts who set foot on the Moon for the first time in 1969 brought back samples they collected from there. Scientists examining them realized that they resembled the basalt rocks of the world. These are the kind of rocks you might find around the world's largest active volcano in Hawaii. Even more interestingly, they found that the elements on the Moon have exactly the same isotope ratios as on Earth. This is interesting, because all the other rocks from elsewhere in the solar system, in other words, the materials found in meteorites falling from space, have different isotope ratios. This shows us that the Moon and Earth materials are very, very similar. There are also huge craters on the Moon's surface. Some of them are so big. However, it can occur as a result of the impact of meteorites hundreds of kilometers in diameter. In the region of the inner planets during the formation of the Earth in the early times of the solar system. Such large celestial bodies may be circulating. This idea brought a new hypothesis to scientists' minds. If a planet-sized celestial body collides with the Earth, could it lead to the formation of the Moon? It is very difficult to understand this question with mathematical calculations on paper. So in 1972, astronomers developed computer software. This program is used to simulate the accretion process in the early solar system. It was a crude attempt made with the possibilities of that time. Astronomers will be able to crash into it near Earth. They wanted to find out if there could be other celestial bodies. If there is another such object and it hits the Earth, could it create a moon-sized satellite? According to this primitive computer simulation, yeah. Such a thing could be possible. And thus the most valid idea ever developed was born. The Great Collision Theory. 4.5 billion years ago, there was a hypothetical planet called Theia. This Mars-sized planet was shattered in a collision with Earth. Some of it was scattered over the Earth. The remainder formed the Moon. Nor did it disappear completely, according to ancient planetary theorists.
What do you do?
Some fragments may still exist at Lagrange points 4 and 5.
Question everything.
Collision hypothesis with the planet Theia. As well as explaining how our satellite, the Moon, came into being. For a body the size of the Earth's core itself. It may also explain why it is much larger than expected. Theia's core and mantle may have fused with Earth's core and mantle. Many simulations have been made since that first computer program in 1972. Collision models were studied. Studies have been made on how the particles will behave and how they will affect each other. Scientists believe that the upper layers of the Earth completely melted after the impact. This great collision also initiates the rotation of the Earth. It also significantly distorts the Earth's shape. In the simulations made to date, after the big collision, of materials scattered around the world, merged in less than a year, it was thought to have formed the Moon. However, according to the most recent study published in October 2022, this event could have occurred within hours. The simulation used in this research to study the origins of the Moon or other giant effects. One of the highest resolution and most detailed studies to date. In a way that previous studies could not see because the supercomputer was used. This study allowed to reveal new behaviors of particles. In this new simulation by NASA and Durham University, hypothetical planet Theia is starting to approach Earth. And this mass, the size of Mars, collides with the Earth. The debris scattered into space initially turns into not one, but two separate celestial bodies. The object, which is farther away and smaller, becomes our natural satellite. The gravitational pull of the larger piece nearby is also stronger, so it merges with the Earth. Just then, the Moon is in a much wider and stable orbit. The grand collision theory is by far the most acceptable explanation for the origin of the Moon. The universe is full of collisions like this. Even now, who knows where and what kind of collisions, mergers, drifts are taking place. Scientists have determined which factors played a role in these collisions. How well they can simulate, how well they can analyze. How a planet transforms. Understanding that our own planet could become habitable just like our Earth. We'll be so ready. The more we learn about how the Moon was formed, the more we discover about the development of our own Earth.